Portfolio Management, Risk and Return, Part 2. In this reading, we will talk about the capital market theory, and the focus here is on coming up with the capital market line. We will then talk about the pricing of risk and the computation of expected return. The idea here is that when investors take risk, they obviously expect a return, and the return represents the price of taking risk. Obviously, investors who take on more risk would like to get more return, and that's what we will discuss in section 3. Then in section 4, we will talk about the capital asset pricing model, which is one of the most basic methods of taking risk and a particular kind of risk, and based on that risk coming up with an expected return. Then we will go beyond the capital asset pricing model. We will talk about limitations of CAPM as well as some extensions to CAPM. Section 6 deals with different portfolio performance appraisal measures, and in section 7 we will talk about the applications of CAPM in portfolio construction. Capital market theory, capital allocation line. This is something we have seen in the previous reading, so we will simply review the content. Investors have different views of the market, and therefore investors will create different optimal risky portfolios. Investor A might come up with one particular optimal risky portfolio. Investor B could easily come up with another optimal risky portfolio because he has a different view of the market and hence will pick different securities in his optimal portfolio. Because A and B have different optimal risky portfolios, they will have a different capital allocation line. The capital allocation line, as we saw in the previous reading, starts from the risk-free rate over here and connects this point to the optimal risky portfolio. This becomes the capital allocation line for A. For portfolio B, the capital allocation line will look like this. This is Cal B. The vertical axis is the return of a portfolio. The x-axis is the risk. These lines are supposed to be straight. Now you might be wondering whether there is a unique optimal risky portfolio. If we assume that there is homogeneity of expectations, which means that all investors or investment advisors have a similar view of the market, they expect the same returns from securities, they expect the risk to be the same, and the answer is yes, as long as we assume homogeneity of expectations. What this means is that all investors or all investment advisors have the same expectation related to every single security. In other words, if we have security A, B, C, and so on, all investors have the same expectation about the return of A and the risk of A, the same expectation about the return of B and risk of B, and so on. In addition, they also have similar expectations about the correlation between different securities. If that indeed holds true, then we say that we have homogeneity of expectations, and then all investors or all investment advisors will construct the same capital allocation line. This is called the capital market line. Let's look at how this works. Again, the y-axis is the return, the x-axis is risk. If all investors have the same expectations, they will only create one efficient frontier. So this is our efficient frontier. If there is only one efficient frontier, then there will be only one capital allocation line, which will start from this point, which is the risk-free rate, and it will be tangential to the efficient frontier. This point is called the market portfolio. It represents the optimal risky portfolio when all investors have the same expectations. Essentially, what we are saying is the following. The CML is a special case of the capital allocation line where the efficient portfolio is the market portfolio. What we now need to do is derive the equation for the capital market line, and we'll use this basic relationship which says that y is equal to the intercept plus the slope times x. In our illustration, the y is the expected return on the portfolio. This is equal to the intercept, which is the risk-free rate, plus m, which is the slope. Let's determine the slope of this particular CML line. The slope is the change in y over change in x. Change in y is this distance over here. This point represents the return on the market, and this distance then is Rm minus Rf divided by change in x. This point over here is the risk of the market. So this distance is simply the risk of the market. That then becomes our slope multiplied by the x variable, which is the risk. What we have done here is derived the equation for the capital market line. The return of a given portfolio is equal to the risk-free rate plus the Sharpe ratio. Note that the slope is actually the Sharpe ratio. It is the excess return divided by the risk, which tells us the Sharpe ratio, and then multiplied by sigma p. This is the Sharpe ratio of the market, or the optimal risky portfolio. Points along the CML represent a combination of the risk-free asset and the market portfolio. At this point, we are 100% invested in the risk-free asset. At this point, we are 100% invested in the market. Here, we are invested 50% in the risk-free asset and 50% in the market. As we get closer to M, the weightage in the market portfolio increases. This concept is exactly what we discussed earlier with the capital allocation line. The only difference is that if you have a homogeneity of expectations, then the efficient portfolio becomes the market portfolio, and this line is our capital market line. I have talked about the market several times. So what exactly do we mean by the market? Theoretically, the market includes all risky assets or anything that has value. The market should contain as many assets as possible, but it is not practical to include all assets in a single risky portfolio. Not all assets are tradable, and not all tradable assets are investable. If you take the Eiffel Tower, for example, it is an asset, but it is not tradable. Similarly, human capital is not tradable. You can have a tradable asset such as Class A shares in a given country, which can only be bought and sold by nationals of that country. For people who are not domiciled in that country, these shares will not be investable. Practically speaking, we use major stock market indices as a proxy for the market. If we take the US context, then the S&P 500 index is often used as the market's proxy. The S&P 500 represents approximately 80% of the US stock market capitalization, and hence is a reasonable proxy for the US stock market. Let's consider a simple example. I want you to try and do this before you look at the solution. Here is what you should come up with. We have return on the y-axis, risk on the x-axis. The capital market line starts here at the risk-free rate of 10%, and it passes through the market portfolio, which has a return of 16% and risk of 30%. This point has 100% weightage in the risk-free asset. As we move up this line, the weightage in the risk-free asset goes down and the weight in the market portfolio goes up. At the halfway point, we have a 50% weight in the risk-free asset and a 50% weight in the market. At the three-quarter point, we have a 75% weight in the market and a 25% weight in the risk-free asset. So this is the point that we are being asked to identify. Next, we need to figure out the risk and return at this point. There are several ways of coming up with the risk and return. The simplest is to look at the line and come up with our numbers. Here is our capital market line. We are 75% of the way across. Therefore, the risk of the portfolio is equal to 0.75 multiplied by the risk of the market, which is equal to 0.75 into 30, which is equal to 22.5. Notice that if we were to write an equation, then the equation would be sigma p, which is the risk of the portfolio, is equal to weight of the market portfolio times the risk of the market portfolio. That's exactly what we have done. What about our return? Return of the portfolio at this point can be read off using this picture. The return is equal to 10 plus this distance. This distance is 0.75 into 6, 6 being the difference between 16 and 10. We can say 10 plus 0.75 into 6, which is 14.5. That is our return at this point. In terms of a formula for the return, we can say that the return is a weighted average of our two assets. The two assets here are the risk-free asset and the market. If we look at the weight of the risk-free asset, that is 0.25. You can multiply that with the 10%, which is the return on the risk-free asset, plus 0.75 into 16, which is the return on the risk-free asset, and this will also give you the same answer. Now I want you to do example 1 from the curriculum. So far, our discussion has focused on the part of the capital market line that is between the risk-free rate and the market. If you notice, in this region, we are investing in a combination of the risk-free asset and the market portfolio. When we invest in the risk-free asset, we are actually lending money to the government. Therefore, this part of the CML is also sometimes called the lending portfolio. The part to the northeast of the market portfolio is called a leveraged portfolio or a borrowing portfolio. The reason is, to get to this part of the CML, we need to borrow money and invest the borrowed money in the market. This point L, for example, can be reached by borrowing 25% of our equity and then putting our 100% equity plus the 25% borrowed amount into the market. When we do that, we are clearly taking more risk. As you can see, this is the risk of the market and this is the risk of the leveraged portfolio. We are taking more risk and here we are also getting a higher expected return. On the right hand side, we look at a leveraged portfolio where the borrowing rate is different from the risk-free rate. This point represents the market again, but now let's say that our borrowing rate is higher than the risk-free rate. And just to use numbers, assume that we are continuing with the example we discussed on the previous page where the risk-free rate is 10%. In this picture, we assume that the borrowing rate is 10%. But what if the borrowing rate is higher? Say the borrowing rate is 12%. Then the slope of the CML after the market portfolio is going to be less than the slope over here. You can recall from our previous discussion that the slope is given by the return on the market minus the risk-free rate divided by the standard deviation of the market. And if we use the numbers that we have on the previous example, then the return on the market is 16 minus risk-free rate is 10 divided by 30. This is 6 over 30. Over here, the borrowing rate is relatively high, and the slope is going to be return on market minus the borrowing rate divided by risk of the market. Plugging in the numbers, return on market is 16 minus the borrowing rate is 12 divided by risk of the market is 30. So here the slope is 4 over 30, which is less than 6 over 30. Intuitively, this makes sense because we have a higher rate and the extra return we get per unit of risk is less compared to the extra return per unit of risk with this portfolio. I want you to do this exercise now before you look at the answer. Here is what you need to do. The weight on the risk-free asset is minus 0.5. Minus because we are borrowing, and 0.5 because the amount borrowed of 50,000 is 50% of the amount of this person's own money that is invested. W2 represents the weight in the market, which is 1.5 because the amount that is invested in the market is 150,000. The total weight has to add up to 1, and we see that minus 0.5 plus 1.5 is equal to 1. The expected return on the portfolio is W1 into the return on the first investment, which is the risk-free return, so minus 0.5 into 10 plus 1.5 into 16, which is the return on the market. You do the maths and you should get an expected return of 19%. In terms of the risk, we simply have the weight in the market portfolio, which is 1.5, multiplied by the risk of the market portfolio, which is 30. So the risk on the portfolio is 45. Graphically, here is what we are doing. This point represents the risk-free rate, 10%. This point represents the market. Expected return is 16%. Standard deviation is 30. Since we are borrowing, or this investor here is borrowing, we are going to be to the right of the market portfolio. Clearly, because of the borrowing, the risk is higher than the market portfolio, and the expected return will also be higher. That expected return is 19% from here, and the risk is 1.5 times 30, which is 45. So this is the point where we are at. Now I want you to do example 2 from the curriculum. Next, we look at a situation where the amount that needs to be paid on the borrowed amount isn't 10%, it is actually 12%. So try this before looking at the solution. The first thing you should do here is draw the picture. Notice that this part of the line is exactly what we had before, but now since Majid is borrowing at 12%, the slope over here is less. The lower slope indicates that for a given amount of risk, the extra return will be lower, and that makes sense because the borrowing rate is now relatively high. Given that Majid is investing 50%, the weights are the same as what we had in the previous example. So the risk of this portfolio is the same as what we had on the earlier slide. It would be 30 which is the market risk multiplied by 1.5. But the return is going to be lower. To come up with that return, we use a basic mathematical concept. This is the change in y, this distance over here. That is equal to the change in x, which is this distance, multiplied by the slope. The change in x is 15. The slope is 16 minus 12 over 30, where 16 is the market return, 12 is the rate that is being paid, and 30 is the market risk, and we've seen this before. So the change in y then is 2, that number is 2, and the expected return on the portfolio is 16 plus 2, which is 18. As expected, this number is less than what we came up on the previous slide, and the number there was 19%. Now I want you to do example 3 from the curriculum.